Okay, I'm going to start over here a second. I am going to talk about the rates of change for quadratics, which has to do with the change in the speed over time for a parabola. It's not linear like when you did Algebra 1. It's curved, so there's going to be rates of change varying throughout the time on the parabola, and even some negative rates of change as it's coming back down. This equation is showing as the initial that's being launched 64 feet per second from a platform 80 feet high. Sorry, I'm repeating myself for you guys. What's the initial velocity of the object when it was initially launched? Well, that's your 64 feet per second. What will be the object's maximum height? Well, that would mean that we want to find the max on that parabolic. This would be 80. So I'm just kind of giving you a little pictorial of what's going on. And the initial velocity of the object was 64. The maximum height is going to occur at the vertex. So we can do that without a graphing calculator by doing the x value of the vertex is the opposite of b over 2 times a. So I'm going to do it without the grapher. X equals the opposite of 64, which is your b value would be negative 64, over 2 times a, which is negative 16. Okay, that gives you negative 64 over negative 32, which equals 2. So 2 is the time, but it's not the height. So basically, if you find the vertex, which is at 2 something, and now I'm going to plug in 2 in here, negative 16 times 2 squared plus 64 times 2 plus 80, we're going to find out what that is. This would be negative 16 times 4, which is negative 64. 64 times 2 is 128. And then plus 80. Negative 64 plus 128 is 64. So we get 64 plus 80, which is 144. The maximum height is the second value. It's the y value. So it would be the 144 feet. How many seconds have elapsed? Well, that's the x value of the vertex. So it would have been 2 seconds that took for it to reach its maximum height. All right, now we will definitely want to go to the graphing calculator so we can just fill in the table. And otherwise, you could do it without it. You just have to keep plugging in numbers. So I think it'd be a little more valuable to just go in the grapher. But I do want to remind you, okay. I was using this earlier, so was this 64 instead of 60 there, right? And what was the initial height again? Was 80? I'm just adjusting this equation. And then I need to delete that. Okay, and then I'm going to get rid of this. I want to go to my line 2. See what happens here. Oh, I have a window that's set differently than yours. And I also want to get rid of the line 2. So I'll have to do this properly, clear. Okay, are you guys on Zoom 6? Yours looks like this. Okay, so it doesn't really matter. We're going to want to find the maximum. So if you want to adjust your window, we can hit Zoom 0, which would be a zoom fit. You don't have to do that to see. You could actually just find the max between. I don't like what's going on here. It didn't do what I was expecting. I'm going to go back to Zoom 6. Oh, I probably just froze my calculator. So I'm going to reset it. Have you guys, are you seeing it? Well, I'm glad you are. Okay, I'll get there. Now, I'm going to go into the table so I can fill in that table. So it really doesn't matter to me that I see the graph. So I'm just going to hit second graph since that wasn't working out for me right then. There's your table. Okay, under second graph, everybody know where that is? All right. And so what values do we need? I think we need 1, 2, 3, 4. exactly. 128, 144, 128. And this was 128 again. Ooh, that means they're coming back down, right? And the 80, and then what was 0? Okay, find the average rate of change in height. This is what's new right here. None of the rest had been new. The average rate of change in height from 1 to 2. All right, that would be y2 minus y1 over x2 minus x1, just like you did slopes back in Algebra 1. That stands for the rate of change. So if you're looking at the seconds being 1 to 2, the y parts are going to be the height, and the x parts are going to be the time. And so we're going to do 144 minus 128 over 2 minus 1. And that's going to give us, I don't subtract in my head here. That's 16. Oh, that's 2 minus 1, not times. So that'd be 16 feet per second. Okay, then an object is dropped. If an object's dropped, there's no initial velocity. There's the equation. The initial height was 60 feet. How long must it fall to reach a height of 28 feet given this equation? Well, did I skip something? I did? What did I skip? Oh, I didn't do the second part. 3 to 5. Holy cow. 3 to 5. Oh, 5 seconds. Was this 0? It was? 0 minus 128 over 5 minus 2. I did forget to do that one. Negative 128 over 5 minus 3. 2. I was thinking the answer. Negative 128 over 2. That's going to be negative 64 feet per second. What does that mean? That it's negative. Anybody? What's happening? What? Yeah, it's coming back down, okay? And it's actually getting to be going pretty fast. Okay, it's coming back down between that, on that interval. Okay, an object is dropped from a roof. That means there'd be no initial velocity, as I said earlier. How long does it take to reach the height of 28 feet above the ground? Well, this was your h sub 0. I'm thinking here we're going to put in that for h. So if we put in 28 equals, oh, that's part B. So there was no initial height. So 0 feet per second for the initial velocity at least. Okay, how long will it take for the object to reach the desired height? That's where we're going to go ahead and put 28 in. So I go ahead back up here. Negative 16t squared plus 60. We can do this algebraically by subtracting 60. That'd be negative, what's that? Negative 32? Yes, it is. It's just not showing that thing at the bottom. At least it supposedly is. If it's not, then I'll be in trouble. I won't be in trouble. I'll just have to do it over. You would subtract 60. What? Negative 32? Okay, and then if you divide by 16, negative 16, you're going to get positive 2. And so we're going to have to take the square root. And a reminder, that would be 2 solutions, but why are we going to, or what one are we going to actually consider? The positive one, because it's talking about time. So I need to figure out what the square root of 2 is. So I grab my trusty calculator. Since I don't know that by heart, I get out of where I was. It's my quit. Second, x squared, get your square root symbol, 2, and then it's going to be small. 1.41. So 1.41 seconds. Okay, what is the height at 1 second, the height at 3 seconds, and what's the average rate of change during this time period? All right, so we're going to have to, you could plug in 1 if you like. Okay, so that'd be negative 16 times 1 squared plus 60. Okay, that would just be negative 16 plus 60, which is 44 feet. And then after 3 seconds, negative 16 times 3 squared plus 60, I think we're going to get a negative answer there. Negative 84. Now, let's talk about that for a minute, because I'd like to put an oops next to that. What does that mean? Oh, it's really going down. Where is it? It's under the ground. Could something literally go 84 feet under the ground unless it was a projectile missile or something? You know what I'm saying? So it's not feasible, but we're going to go ahead and calculate it anyway, just because I want you to know how to calculate the rate of change. But I'm writing oops because technically it can't go negative 84 feet into the ground. All right. The ground would stop it somewhat and slow it down. So that would be a whole nother scenario. All right, so what's the average rate of change, though, during this time period? If we were to go with these numbers, it would need to be negative 84 minus 44 over 3 minus 1. And that's negative 130. Wait, can I add? I'm adding 132 or 20? No, 128. Yeah, negative 128 over 2, which is negative 64 feet per second. And can't happen. It can't really happen. But we know how to calculate it. That's what counts. All right, so if it was able to do that, then that would be the rate of change. Okay, we got a projectile fired upward from a height of 120 feet at an initial velocity of 60 feet per second. When will the projectile be 150 feet above the ground? All right, so this is your equation, which you actually should be able to write on your own. Oops, didn't mean to write over that thing. Where will it be? There should be two answers, because think about it. If it's coming off 120 feet, that's where it starts. That'd be like your y-intercept. And then it's going to go up and then come back down. So if there's two answers, that would be because if you draw a horizontal line, you're going to intersect the parabola twice. So I would call this 150 feet, and then I'm going to check for the intersections. So at what time will the object reach the desired height on the way up? That would be the first intercept. And on the way back down, that would be the second intercept, where they intersect. So let's see what our calculator will help us with. All right, it was negative 16x squared plus 60. And then I've forgotten, what was the initial height? 120? I did remember. Okay, now if I just hit graph, I'm not going to see everything I'd like to see. Okay, so what would maybe be a window? And I'm going to go back to y equals a second. We would like to know, and I drew you a picture, how can I get that to graph the 150? In y2, put 150. Now, if I want to see it, I'm going to have to adjust my window. So I'm going to guesstimate about how high up to go. I'm just worried about I saw the parabola basically, okay, but I didn't see the top of it. So I'd like to see the top. So I want to go over 150 so I can find out where that intersection is. So maybe I'll put in 180 or something. I don't know. I'm just making something up to see if it works. Okay, beautiful. So I've got I can see both intercepts when it occurs, when it hits 150. So I'm going to second trace and calculate the intersection, choice 5. It's going to give you the first intersection. If you hit enter, enter, enter. Okay, I don't know what I just did, but I'm going to start over. Second trace, something didn't happen for me. Choice 5, telling me to put in the parabola, enter. Enter again to put in the line, enter. And then enter again to guess. Maybe I had it and I just didn't see I had it. 0.59 seconds was the first x-intercept. Okay, go to the hundreds place, please, on those times. All right, now I'm going to try to find the other one, but let me tell you something. You got to do this. You're going to have to arrow to the right. Otherwise, it's going to keep on giving you the same one. Oh, thought I might be on the problem. Let me see if this will work. So hit second, trace again, choice 5. Oh, it bounced right back there. So now I guess I prematurely arrowed over. So I need to do that over again. Arrow, arrow, arrow till I get way over here. I'm just like almost on it right now, but I'm gonna hit enter, 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 and now it gives me that one. So I got 3.16. So on the way back down, it takes 3.16 seconds to reach the 150 feet. Okay, go back to your grapher, and we're gonna fill in this chart using the table. Does everybody know where to get the table? You hit second, graph. All right, and we don't want the red one. That's just that constant line. So we're doing the blue. The first list was our Y1. Let's see, 120, 164, 176. Okay, I didn't need the 0 one. Now I forgot what they are. 156, 104, and 20. Okay, find the average rate of change in the height from time of 2 to 4. So we take our time of 4 and look at the height, 104. Subtract from that the time at 2 seconds, 176. And then divide that by 4 minus 2, which is 2. So I need the difference. That'd be 72, right? Negative 72, sorry. Divided by 2 would be negative 36 feet per second. That means it's coming down. Okay, why don't you try the next? What number's 3? Oh, this isn't 120, it was 20, wasn't it? Let me fix that. At 5 seconds, it was 20 feet high. That didn't make any sense to have it going back up. All right, what do we got from 1 to 3 seconds? Are you guys getting -4? I hope you're calculating it. You should have gotten -4 feet per second. Now check out the difference between that and the previous answer. It's going pretty slow because that's really close to the top. All right, so it just turned over and it's coming down. That's a mess the way I wrote that. Fix it. Do you need help or how we're getting the -4 feet per second? Okay, and then 4 to 5 seconds. Oh, 20 minus 104. I don't know why I'm showing this one when I didn't show the last one, but divided by 5 minus 4, which is 1. Okay, and that's -84 feet per second. So you see how it's speeding up? Oh, well, actually, this was after that. So the earlier time was slower, and then it kept going faster and faster until at some point it hits the ground. Okay, that's all I've got to say about that. So you're going to need to know how to do a rate of change. Your assignment, guys, is the review. And Monday we'll be going over questions on the review. And right now I can answer any questions you might have on the last homework. Our unit test is Tuesday. It's in your packet. It's the last pages. Yep, it's the last 3 pages. Okay, I'm going to sign out Heimer time for now, and then I'm going to answer questions to those students that are here today.